Hello, everybody. This is Algebra, Chapter 2, Lesson 5, or 2.5, Combining Like Terms. Today is a very easy lesson. It's one of my favorites. We are combining terms that are alike. So if we remember from our earlier discussions, a term, right, in math, is any set of coefficients and variables, or numbers and letters multiplied. For example, here's a term, 35x. That's a term. You have your number, which is the coefficient, and technically speaking, it's being multiplied by some variable called x, right? So in reality, this is really 35 multiplied by a letter called x. Now, what is really going on is that this 35 tells you how many times this variable is added to itself. In reality, this term is actually saying it's x plus x plus x plus x. That's happening 35 times. So we see that it is 35 x's, right, added to themselves. We've also learned that terms can look like this. You could have a negative 3y squared, right? You could have a 7b. You can have a term that looks like this, where it is just the letters by itself, by itself. So xy plus 3b. This is a term, and the 3b is a term. If I added the negative 7b here, it would be negative 7b. And each of those are terms by themselves. You have the coefficient number times the variable. Today, what we're going to be doing is we're going to be putting them together and adding, subtracting them. So for example, what we need to understand first is what terms really mean. So let's imagine for a second that you had apples. And for the sake of ease, we're going to say that an apple is the letter A. 1A equals 1 apple, right? So in this example, I've got 1, 2, 3. I have 3 A's, right? If I added these 3 A's together, how many apples would I have? Well, you know this, right? 1A is 1 apple, so that's 1 apple here. That's 1 apple there. That's another apple there. Altogether, you have 3 apples. But since we are able to say that apples is equal to A, in reality what you have is, or in math rather, what you have is 3A, 3 apples. Now let's say I tried to add a banana to that, right? And we call banana B. So I've got my B over here, and that is for banana, right? Every time you see a B, it's the variable banana. If I had 1, 2, 3 apples plus 2 bananas, what's my situation? Well, it's simple. I've got an apple here, an apple there, an apple there. So altogether, that's 3 apples, right? 3 A's. Now, if I have these 2 bananas, it doesn't change how many apples I have, right? It just changes how many bananas. And how many bananas do I have? I've got 1, 2 bananas. So I've got 3 apples plus 2 bananas, or 3A plus 2B. And in reality, what this is saying is 3 times A, or there are 3 apples. Apple plus itself 3 times. And what this is saying is 2 times B, or that there are 2 B's, 2 bananas. Okay. Now let's say I come along, Mr. Thomas comes along, and he adds another 2 apples. So now what do I have? Well, in reality, I have the original 3 apples plus these 2 new apples. Nothing happened to the bananas, it stayed the same. So now I have 3 apples plus 2 bananas plus 2 apples, right? 2A. But just because it's a new situation doesn't mean I don't have a grand total of 5 apples. In reality, I have 1, 2, 3, 4, 5. And that's what you can do. If they have the same terms and we're on the same variables, you can just add those numbers together. So 3 apples plus 2 apples is 5 apples. Nothing happened to the banana, so it's 5 apples plus 2 bananas, or 5A plus 2B. And that would be your final answer. There's nothing else you can do here. You've added your apples and you've added your bananas and you've put like with like and the same with the same. That's it. So let's try a couple examples. If I had 5, oh, what's a good word for n? 5 nickels. There we go. 5 nickels. N stands for nickels. Okay. 5n, and then somebody came along and added another nickel to my pile. Well, how many total nickels do I have? Well, this is 1n, right, in reality. One second, my pen stopped working. I'm sorry, 1 second, give me a moment. There we go, and now we're back. Okay, so let's say I had, like I was talking about, 5 nickels, and n is nickels, right? And somebody came along and added 1 more nickel. How many total nickels do I have? Well, it's a simple situation, isn't it? It's 5 nickels, 1, 2, 3, 4, 5, plus 1. Altogether, that's a total of 6 nickels. 1, 2, 3, 4, 5, 6. In the same way, you could simply say, instead of 6 nickels, that's m, sorry, you could say 6n. 5 plus 1n, 5n plus 1n is 6n. Now, let's say it was 5 nickels plus 1 nickel minus 2 pennies. What would your situation look like now? Well, it's very simple. You deal nickels to nickels and pennies to pennies. You have 5 nickels plus 1 nickel, that's 6 nickels. And nothing really changed with the pennies except we're taking away 2 pennies. So in the end, my equation remains 6 nickels minus 2 pennies. Now, because we know how much a nickel is worth and how much a penny is worth, we can solve this. But for today's purposes, we're only talking about like terms, so that's where we would stop, right? 6 nickels minus 2 pennies. You can't combine pennies and nickels because they're just not the same thing, right? Now, in reality, I know that pennies and nickels represent money, but for today's purposes, the N and the P mean unlike terms, right? Remember that term, unlike? That they are not similar. If they're not similar or exactly like, you cannot put them together. Let's try another one. Let's say you had some exponents. 6 x squared plus x squared minus 9x squared. All right, what happens here? The first step when you're trying to solve combining like term situations, when they say simplify, what they want you to do is, can you figure out a way to combine these so that's the simplest answer? All right, so first we're going to do it the fast way, and then I'm going to show you what went on in reality. First, I notice that there are 3 terms here, 6x squared, positive x squared, and negative 9x squared, right? And in reality, this x squared is 1 times x squared, so it's a 1x squared, because there's only one of them. So the question is, can I put these together? And the answer is yes. Why can I put these together? because they all have the exact same variable, x squared. All right. If there was another variable over here that said plus 3x, that is not the same variable. Notice that the 3x is not the same as x squared because you are missing the square. What 3x means is 3 times x, or x plus x plus x. That is different than x squared. X squared is x multiplied by x, right? X multiplied by x. It's the same thing as saying 2 plus 2 plus 2 versus 2 multiplied by 2. They're two different things, okay? So let the camera catch up with what we're doing here. See what I was saying? 2 times 2 is not the same thing as 2 plus 2 plus 2, right? Let's get back to the problem. So now that I know that I have 3 like terms in this problem, I can combine them just by obeying what their signs say. So I've got a positive 6x squared plus 1x squared. So like altogether, 6 things plus 1 thing is 7 things. 7 what? 7x squareds. Now I just finish out with what I know. 7 things minus 9 things is -2, right? Because it's really 7 minus 9. 7 minus 9 is -2. -2 what? They both have the same variables, -2x squared. And that, ladies and gentlemen, oh, let me make that a little smaller. That is your final answer. -2x squared. That's because all of them had the same variables at the end, the exact same variable at the end. So therefore they were like terms. Let's do the exact same one now with unlike terms, right? So let's say it was 6x squared plus x squared minus 9x squared. Now here's where we're going to mess it up, okay? We're going to go positive 6x plus 1x. All right, so now my first step is to identify what are all the terms. All the terms are positive 6x squared, positive x squared, negative 9x squared, positive 6x, and positive 1x. Which one of these can I put together? Well, the color coding should help you in this situation, but you should recognize that it's everything with the exact same variable. The 6x squared, the x squared, and the 9x squared. The 6x and the 1x do not have the exact same variables as the x squared because they are missing their squares, right? So what we can do is we can say 6 plus 1 is 7x squared. There are 7x squareds minus 9x squared. And what is that? That's -2, like we just determined. All right, now I have these two terms. 6x's plus 1x is 7x's, right? And then I add it down here. And so I say to myself, all right, I've got -2x squared plus 7x. Can I combine these? The answer is no, because in reality, this is an x squared and this is just an x by itself. So that's all we can do. That's as far as we can get. This is your final answer. -2x squared plus 7x. All right, now we're just going to run through some examples. Let's do 3 or 4 of them, and then that will be it for today. All right, let's do this one. 3x minus 6x's minus 2y's plus 8y's. Let me translate what this means real quick. Actually, let me do it in a different color so we can see the color coding. So this is minus 2y plus 8y. All right, what does it mean? 3x in reality is 3 x's, so it's x plus x plus x. In reality, negative 6x is minus 6x's, so that's really negative 1, 2, 3. Oh, I'm getting lost. Hold on. X plus X plus X plus X plus X. Is that 3 of them? One more. So you see how there are 6 X's? And then the negative 2y is literally negative y plus y. And 8y is literally 8 y's. I'm not going to draw all of them because I can't fit them. So that's literally what's going on. So if you took away 3 x's, you'd get 1, 2, 3 on both sides, which would leave you with negative 3 x's, right? 1, 2, 3. Negative 3x. And then take away 8, take away 2. 1, 2 is what? 6 plus 6y. And let's check the algebra to see if that's correct. I'm going to write that in green, negative 3x. All right, let's check the algebra on that. It should equal the same thing. So first I look for the like terms, the x and the x, the y and the y, those are the same. So I should be able to combine these, and I should say 3 minus 6 is negative 3. Negative 3 what? Negative 3x. And then over here, negative 2y plus y, which is really 8 minus 2y, which is the same thing as saying positive 6. Positive 6 what? Positive 6y. Yep, they are equal. They are the same. It worked out for us. We have negative 3x plus 6y on both sides. Sorry that the camera is taking a little bit long to fill in there. All right, let's try a couple more. Let's do, oh, here's a nice one. 5y minus 10y plus 3y. First question. Do I have like terms? And I think I do. I've got 5y's, 10y's, and 3y's. I can do that. I can put those together. So let's just start at the beginning. What is 5 and negative 10? 5 plus negative 10 is negative 5y. All right, what is negative 5y plus 3y? That's just going to be negative 2y. And sure enough, I should have negative 2y's left. That is my final answer. Later on, you'll be able to substitute the variable for some type of number, but we are not there yet. We are still just combining like terms for simplifying purposes. All right, let's do another 2. Ooh, let's do some squares. So now we have c squared plus c squared plus c. All right, now which one of these can we put together? Which one of these are exactly alike? Well, in reality, first we know that this c squared is a term, this c squared is a term, and this is a c by itself. If we broke this down, what does each mean? C squared is really c times c, plus c squared again is just really c times c. That's how you get a square. And 1c by itself is just a c. So which one of these are like terms? Well, if you look at it like this, it's pretty obvious, right? Because in reality, if you switched out the c's to a number, it could be 3 times 3. This would be 9. Therefore, this would be 9. And this would just be 3. And those are not the same numbers, right? So you can't put them together. Well, at least in this respect, when we're combining like terms. So what this is this is 1c squared. This is another 1c squared. And this is just 1c. So I can only put together the c squared. So how many c squareds do I have here? I have 2 c squareds. And how many 1c's do I have? I just have 1c, but I don't really need to write the 1. So there you go. So it's 2c squared plus c, and that is your final answer. All right, last one coming up here. Here it is. Nice. I've got 2x plus x plus 7x squared minus 10x squared. All right, which ones can I put together? Well, it should be obvious by now. This term and this term have the exact same variable, x and x. So you can put them together because in reality, this is not just an x, it's 1x. So 2x plus 1x is 3x. So that takes care of these. Can I put together the 7x squared with it? No, because x squared and x are not the same variable. But I can put together this x squared and this x squared. So reality, it's 7. It's the 7 here minus the 10 here, because you just obey whatever the sign is in front of the term. So 7 minus 10 is -3. So it's -3, 3 what? X squared. And that is your final answer, 3x minus 3x squared. Now, when you get to higher math, they want you to put the thing with the highest power in front. So in reality, it's -3x squared plus 3x, because this is a positive, right? It's positive 3x. And there you go. You cannot combine the x squared plus the x. They are unlike terms. So today you learned about combining like and unlike terms. Make sure that the terms are exactly alike if you are going to add or subtract them. And then finally, make sure you pay attention to the signs, because the signs will affect your final answer. All right, we will see you in the next video.